Dear students, I welcome you for the today's lecture related to the root locus diagram and its different numericals. While determining or drawing the root locus diagram, first one has to write down the characteristic equation. Characteristic equation is nothing but 1 plus the transfer function of open loop transfer function. And what is open loop transfer function? It is nothing but disconnected from the comparator, the feedback loop that is disconnected from the comparator and is the product of all transfer functions in the control loop. So after obtaining the open loop transfer function, one has to find out the open loop poles and open loop zeros. The values of S for which the open loop transfer function becomes infinite is known as the open loop poles. That means whatever there is in the denominator, all those are your open loop poles. And the values of S for which the open loop transfer function becomes 0 is known as open loop 0. That means the for the different values of S which makes the numerator 0, they are all your open loop zeros. So open loop poles, they are indicated by the cross. Open loop zeros, they are indicated by the 0 and they are plotted on the complex plane. So the number of open loop zeros are say A and the number of open loop poles are B. So there are B number of branches or loci that will be developed. As many number of open loop poles are there, that many number of branches will be generated. Now all the branches, they will start from the pole and will terminate at the 0. That is, root begins at open loop pole and ends at open loop 0. So for ith order poles, the I number of branches emerge from the pole. So B number of branches that will emerge from the pole, that much. And first condition is that the root begins at open loop pole and ends at open loop 0. So whatever the remaining, that is B minus A branches, that will terminate 0 at infinity. So B minus A branches will terminate at infinity along the asymptotes. Now one has to remember the difference between the branches and asymptotes. The branches, they are follow the axis. On the axis there can be the branches as well as asymptotes. Asymptotes, they are with the dotted lines. Generally they can be vertical, that means an angle of pi by 2 or the angle of 3 pi by 2, or there can be the different asymptotes which is forming the angle 3 pi by 2, pi by 3 or 3 pi by 3. So these are the different angles that will be generated, and depending on these are your asymptotes. Asymptotes, they are different. Axis, that is different, and branches, they are different. So B minus A branches do not have a 0 to terminate. So B minus A branches will terminate at infinity along the asymptotes. So these B minus A branches will follow the asymptotic lines. पहले क्या है? P पोल टू 0. बचे हुए जितने पोल्स हैं B minus A poles, they will follow the asymptotic lines. So locus on the real axis, that is the sum of real poles and real zeros, is odd number. Then the real axis is a part of root locus diagram. So it's a part of root locus diagram. Odd axis है तो, odd number है तो poles के. It is a part of root locus diagram. So that means it will be on the axis. Then the number of asymptotic lines which emerge, from where these asymptotic lines will emerge, they will emerge from the center of gravity of open loop poles and open loop zeros. So center of gravity is nothing but the summation of poles minus the summation of zeros upon B minus A. Then at what angle these asymptotic lines they will be formed. So I have told you that these asymptotic lines, they can be, generally they are shown with the dotted lines. These are your lines. So in this case, whenever there are two asymptotes, so angle made is pi by 2 and 3 pi by 2. This is what the angle pi by 2 and the 3 pi by 2 angle that will be there for this asymptote. ऊपर का एक asymptote हो गया और नीचे का एक asymptote हो गया. Two asymptotes are there. So angle made is pi by 2 and 3 pi by 2. Then if there are three asymptotes, the angle made is pi by 3 and 5 pi by 3. That is, it will be similar to this, that is pi by 3 and 5 pi by 3. And whenever there is single asymptote, it is the pi that will come into the picture. So this is the pi. It means it is your x-axis or real axis that will be there. Understanding this is more important. The angle made by asymptotic lines, that is calculated by using pi into 2n plus 1 upon b minus a, where n that may have the value of 0, that may have the value of 1, that may have the value of 2, that will depend on the b minus a minus 1. So if b is 3, a is 1, that is 3 minus 2, 3 minus 1, that is 2, again 2 minus 1 is 1. So up to 1, that means there are 0 and 1. So it will have two asymptotes, and which will make an angle of pi by 2 and 3 pi by 2. This is related to the angle made by asymptotic lines with the real axis. Then the breakaway point and the break-in point. Either there will be the breakaway point or break-in point. Breakaway point is the point of intersection of two branches. Now you have to consider the branches and not the asymptotes. It is the two branches radiating from the adjacent poles on the real axis and then follow or lose the real axis following the asymptotic lines. So this is my real axis and the imaginary axis. This is the asymptotic line. Say two asymptotic lines are there. Then if one pole is here, another pole is here, and this is what the center of gravity is there, which we have previously calculated. From this center of gravity, the break asymptotes that will be there, and from each pole what is it? The point of intersection of two branches. Point of intersection of two branches radiating from adjacent poles on the real axis, and then leave the real axis following the asymptotic lines. These are my asymptotic lines. This is my real axis. So, and these are my two poles. This is my one pole. This is my another pole indicated by the cross. So, I am starting from the pole, point of intersection of two branches radiating from the adjacent poles on the real axis. So, from pole, it will move towards the center of gravity. From poles to the center of gravity, and then leaves the real axis following the asymptotic line. Now this is going to leave this real axis following the asymptotic line, and similarly this from this pole it will follow the asymptotic line. So this will be what this is the importance of the breakaway point, because in some problems center of gravity and the breakaway point they can be different. In this example we have taken the center of gravity and breakaway point as the same. The next is the angle of departure, that is calculated by 2n plus 1 into pi plus summation of py minus z minus of summation of py minus p, where n is having the values of 0, 1, 2 up to I minus 1, and py is a particular pole of the order y, and p is not equal to the py. So similarly the angle of approach that will also be calculated, only difference is that of the signs. Now come to the next problem. The transfer function that is given as k into bracket s plus 2 upon s square into s plus 3. So by looking at this, the number of zeros, that is s, which is equal to the minus 2, and the number of poles, that is p1 equals to 0, p2 equals to 0, and p3 equals to minus 3. So the summation of all the poles, that is 0 plus of minus 3, that is nothing but your minus 3. There are a number of zeros and b number of poles. So 1 0 is there, and b number of poles, that is 3 poles are there. Since number of open loop poles are 3, there will be 3 branches. Out of these 3 branches, one will end at the Z1. Since there is only 1 0, one of the branch will start from the pole either of the pole, either P1, P2 or P3, we don't know. That we have to decide it from the value of Z1, which pole that will be going, and terminate at the Z1 while the other two will terminate at infinity. So here we have plotted for 0, 0, pole P1, P2, then pole P3 that is at -3 and the 0 at -2. Now the real axis, okay, then the center of gravity that is to be calculated, that is nothing but summation of P minus summation of Z upon B minus A, that comes as the 0.5. So center of gravity that is noted as 0.5. Then we can plot the asymptotic lines. So where n, in this case B minus A, that is 2. So B minus A minus 1, that is 1. So in this case n will be equals to 0 and 1. For n equals to 0, the asymptotic angle that is pi by 2, and for n is equal to 1, the asymptotic angle that is 3 pi by 2. So we can plot these two asymptotic lines, and two asymptotic lines emerge from this center of gravity. Two asymptotic lines emerge from this center of gravity. So center of gravity is 0.5, and for that we have drawn the two asymptotic lines, making an angle of 90 degrees and making an angle of 270 degrees with the real axis. Now after plotting all these things, we can see that the two poles are at 0, one pole is at -3 and one 0 is at -2, and center of gravity is -0.5. So the real axis between the poles at -3 and -2, poles at -3 and -2, 0, is the part of root locus diagram. Since there is only one real 0 at the right of any point between 3 and -2, सिर्फ यही एक 0 अवेलेबल है अपने पास. So since the locus start at -3 and terminate at -1, so it will start at -3 and will terminate at this 0. This will start at -3 and will terminate at this 0. This is indicated by this bold line. So since the locus starts at -3 and terminates at -2, and the real axis between -3 and -2 is a part of locus, so that the locus begins at -3 and moves along the real axis at the 0, and the value of k changes from 0 to infinity. It will be, every time it will be stable system, because it is in the left hand side of the imaginary axis, which is considered to be the stable. So as the roots, they lie in the left hand side, whatever the value of k will be there, that will be taken as the stable. Next step, what will happen to the remaining two poles? So the angle of departure that is to be calculated by using this formula. Hence, one locus will emerge from the origin and moves vertically up while the other moves vertically down. since they have to move along the asymptotic lines. One moves upward towards the one asymptote, and from the second pole P2, which is also starting at 0, it will follow the asymptotic line. So each will move towards the asymptote and then move along it. So again, this system is stable for all the values of k, as no locus crosses over the right hand side. It moves towards the left hand side. If it would have been moved towards the right hand side, then the system would be unstable. Now the next problem. So in this case, the transfer function is k, open loop transfer function is k upon s plus 1, s plus 2 and s plus 3. So there is no zeros. Number of poles are p, which is equal to minus 1, p2 which is equal to minus 2 and p3 which is equal to the minus 3. So summation of all the poles, value of a, that is equals to 0, value of b corresponds to the number of poles, that is equals to the 3. Since number of open loop poles are 3, there will be the 3 branches, and all the 3 will terminate at 0 at infinity. All the 3 branches will terminate at infinity, because there is no 0 that is available. So b minus a is the number of asymptotes. So there will be the 3 asymptotes that will be there. Then the center of gravity, from where these asymptotes they will be generating. So the center of gravity is nothing but your summation of p's minus summation of z upon b minus a, that comes as the minus 2. This is for the asymptotes. So the real axis between the infinity, minus infinity, and the poles at minus 3, and between the poles at minus 2 and minus 1 is a part of root locus. Now this is very important, that is why I have bolded it. The real axis between the infinity and the pole at minus 3. This is the pole at minus 3, pole at minus 3 that is there, and towards the minus infinity, right? So real axis, this is your real axis between the minus 3 and the infinity. तो ये जो है, this part is a root locus diagram part, and between the poles at minus 2 and at minus 1 is a part of root locus diagram. Between minus 1 and minus 2. So between minus 1 and minus 2, इसके बीच में का जो पार्ट आएगा, that is a part of root locus diagram. Since there are two adjacent poles, that is at minus 2 and minus 1, these are the two adjacent poles, that is at minus 1 and minus 2. The real axis is a part of root locus between these poles. Then the loci have to move along the asymptotes. So asymptote its center of gravity is -2. Center of gravity, that is -2, that is calculated in this numerical. So center of gravity is -2. Then the breakaway point, that is to be calculated. So breakaway point is nothing but 1 upon s minus p, summation of all s minus p, which is equal to 1 upon summation of 1 upon s minus z. So in this case, the z, that is 0. So summation of all 1 upon s minus p, that will be calculated as P1, which is equal to -1, P2, which is equal to -2, and P3, which is equal to -3. So this summation 1 upon S plus 1 plus 1 upon S plus 2 plus 1 upon S plus 3 is equal to 0. So after solving that, you will get the logical S value that comes as the -1.42. So -1.42, I have noted the point of breakaway point. This -1.2 is noted as the breakaway point. So what will happen to the asymptotic lines? They will start from the center of gravity. Asymptotic lines, they will start from the center of gravity, and this is making an angle, three different angles that you will get. That is nothing but your pi by 3, pi, and 5 pi by 3. This is your pi by 3. This is your pi, and this is your 5 pi by 3. This line is making 5 pi by 3. So all these three asymptotes, they have been drawn and will be starting from the center of gravity of -2. Then we have plotted the breakaway point at 1.42. So therefore, the locus starting from the -1 will move towards the real axis in the left side and will reach up to this breakaway point -1.42. From this, it will start and will reach to the 1.42 and will follow this asymptotic line. Similarly, from the pole -2, it will move towards the 1.42 and will move towards the another asymptotic line. For this, it is already moved towards the -infinity, as it is the real axis part. So we have plotted the three branches, one starting from -3, second starting from -2, and will follow one of the asymptotes from this breakaway point. Similarly, the third one, that will start from -1, will move up to the breakaway point and follow the remaining asymptote. Now, as we see that these asymptotes may cross the imaginary axis. This asymptote may cross the imaginary axis, and accordingly my path followed by the branch, that will also cross this imaginary axis. That means that may go into the unstable part when it crosses this imaginary axis. As these asymptotes, they cross the imaginary axis. This imaginary axis, it may be crossed by these asymptotes, right? So similarly, my branches will also cross this imaginary axis and will become unstable once they will cross this imaginary axis. Now, how I can, or what values of the k they will be considered to be the stable. For that purpose, you have to use the route test to determine the value of k at which the loci crosses over to the right hand side. For that, you require the characteristic equation, which is 1 plus transfer function of open loop, and after simplification it becomes your s cube plus 6s square plus 11s plus 6 plus k, which is equal to 0. Then you have to plot the route array. So s, that is your odd terms, q1 and q3, they are plotted as 1 and 11. Then the even term, that is 6 and 6 plus k, 6 and 6 plus k. So after that, this value that is to be calculated by multiplication of 6 into 11 minus 6 plus k divided by the 6. So you will get this 60 minus k upon 6. For this, 6 into 0 and 1 into 0, that will become 0. Now then this is to be calculated by considering multiplication of these two things, 60 minus k into 6 plus k upon 6 upon this. So only the remaining term is 6 plus k. So this is my 6 plus k. Here that is having the value of s cube. So I will have the m plus 1 number of rows. That is 3 plus 1, 4 rows, that will be sufficient. Now the location of the pair can be determined, the values of the k, that is obtained from the as square plus b, which is equal to 0 for m minus 1th row. So what is m minus 1th row? This is my mth row. This is m plus 1th row. And this is second row is your m minus 1th row. So the coefficients of the m minus 1th row, they are 6 and 6 plus k. So 6 plus 6 plus k, 6s square plus 6 plus k, which is after simplification you will get the plus minus under root of 11j. So s will have the values of plus minus root of 11j. So that means I have to plot the root of plus minus 11j on this imaginary axis, and this 60 minus k upon 6, the roots lies on the imaginary axis. All the elements of the third row must be 0. So that is what 60 minus k, imaginary axis पे कब होंगे वो roots? For k, that comes as the value of 60. The root lies on the imaginary axis when, if all the elements of the third row are 0. So third row के elements क्या है? One is 60 minus k upon 6 और ये तो already 0 है. तो ये जो value है 60 minus k upon 6, that is to be equated to 0. So what will be the value of k? That is nothing but the 60 will be the value of k. So roots lie on the imaginary axis. All the elements of the third row must be 0. And the location of the pair of roots, that is determined by a square plus b for the coefficients of m minus 1th row. So from here one can conclude that this value of under root of 11 is making it a unstable system, and for the values of k which is equal to the 60, up to that value of the k 60, this system becomes stable, and above the values of the k 60 it becomes unstable. Now the next example, the transfer function of the open loop transfer function is 0.5k into bracket 4s plus 1 upon s into s plus 1 into 0.5s plus 1. So 4s plus 1, I can have the value of s that is equal to the minus 1 by 4, that is nothing but z1 which is equal to minus 0.25. Then for the poles s p1 that is equal to 0, p2 that is equal to minus 1, and p3 that is equal to the minus 1 by 0.5, which is nothing but the 2. So I can do the summation of all poles, summation of all zeros. A is the number of zeros, that is 1, and b is the number of poles, that is 0, minus 1 and minus 3, so we will have the value of 3. Since number of open loop poles are 3, there will be 3 branches. Since there is only one zero, one of the branch will start from the open loop pole and will terminate at the open loop 0, while the other two will terminate at infinity. So other two will terminate at infinity. So there will be the b minus a number of asymptotes that is there. 3 minus 1 which is equal to 2 number of asymptotes. Then from center of gravity, summation of all p minus summation of all z upon b minus a, that is going to give you the value of minus 1.37. So I have plotted a 1.37 value, and from there the asymptotic lines that will be there. There will be two asymptotes that will be there. So whenever there are two asymptotes, that will have the value of pi by 2 and 3 pi by 2. So asymptotes, the angle made by these asymptotic lines, that is calculated by theta, which is equal to the pi into 2n plus 1 upon b minus a, where n which is equal to 0, 1, 2 up to b minus a minus 1. So that will have the value of 1, means up to 0 and 1. Two angles will be there, 0 and 1. For n equals to 0, I will get the asymptotic angle as pi by 2. यहाँ पे n is equal to 0 substitute किया, तो pi by 2 b minus a is 2. So this comes as the pi by 2. Then for n is equal to 1, the asymptotic angle is 3 pi by 2, which is nothing but 270. And the two asymptotic lines emerge from the center of gravity of minus 1.37, making an angle of pi by 2 and 3 pi by 2. So this is the dotted lines shown. They are nothing but your asymptotes, that is starting from 1.37, minus 1.37, and it starts with the pi by 2 angle and the 3 pi by 2 angle. The next is the breakaway point. The breakaway point, that is nothing but 1 upon summation of 1 upon s minus p, which is equal to summation of 1 upon s minus z. So 1 upon s minus 1 upon s plus 1 plus 1 upon s plus 2, which is equal to 1 upon s plus 0.25. That is what related to the 0. So after simplification, you will get 2s cube plus 3.77 s square plus 1.5 s plus 0.5, which is equal to 0. So after simplification, you will get the value of s, that is equal to minus 1.495, and s, that is equal to the 0.195. The other values are of no use. So breakaway point in this numerical, that comes as the 1.495. Why? There is the three poles, that is at 0, minus 1 and minus 2. 0, minus 1 and minus 2. So at 0, at minus 1 and at minus 2, these are the three poles, and 1 0, which is at minus 0.25. So this pole which is at 0 will terminate at this minus 0.2, and it follows the real axis.